Welcome everybody. Now I'm going to start a session where I would be giving you all the geometrical concepts that are required to solve any International Math Olympiad question. In fact, not only International Math Olympiad questions, with these geometrical concepts you will be able to solve any questions that are arising connected with geometry in competitive exams also. And these days you have competitive exams literally for any area of higher education as well as connected with the jobs. So having mentioned that, let me now go ahead and give you the first concept. Now this is a very important concept. This is called as the Apollonius Theorem. Now I'm going to give you a basic form of the theorem, and then I will give you a question where this question was asked in one of the leading competitive exam, and I will show you how to apply this Apollonius theorem. Now imagine you have a triangle. You've got A, B, C, and you have the medians AD. These are the medians. Let me use a different color. So you got a median AD, and then you have a median so they are hitting exactly at the center. That's an important point. It has to be taken into consideration. So this is BE, and then you have another median from C, and this is hitting at F. So let me consider the length of these medians to be as MA, MB and MC. So these are the lengths. Now this particular theorem is actually applied to find the length of the medians, and that is the main utility. So if I were to consider the median AD, then you have to note that the median is starting from A. So this is the vertex. Now since it's starting from A, we will be utilizing AB and AC. So these two sides we will be utilizing. So let me write that formula down for the median AD. So it's going to be AB squared plus AC squared, which will be equal to 2 times of AD squared plus, now this distance is BD, right? So you have to place that distance BD squared. So this is the formula. Now AB squared, I will just retain AB squared plus AC squared is equal to 2 times of AD. The length of the median is MA squared positive. Now BD, now what is BD? If I were to take the length of the sides, now let me take the length of the sides as A here, and this one as B, and this one as C, then BD will be equal to half of BC. But what is BC? BC is nothing but A units. So my BD is going to be half of A. This is what is my BD. But I need to put BD squared. So that's going to be 1 over 4 times of A squared. So if I were to rewrite this, I would have AB squared plus AC squared is equal to 2 times of MA squared positive A squared over 4. And AB is C units, right? The length is C. And AC is B units. So it's going to be B squared. So I have now a beautiful formula which is c squared positive b squared is 2 times of ma squared positive a squared of 4. So this is the formula. You can either write it as c squared positive b squared or b squared positive c squared. It doesn't matter. So this is the formula that I have got for the median AD, which is of length MA. So clearly you can extract MA because you know C, you know B, you know A, and the median MA can be calculated, right? So that's a beauty. In fact, I have just given you for this AD. You can extend this for any side, for the any median. In fact, let me just show you this median. So this is coming from B, right? So how do I write the formula? So let me use this part of the space. So this is coming. So I'm interested in calculating MB. I don't know what is MB, but it's coming from the vertex B. So this is going to be BC squared plus BA squared is equal to 2 times of BE squared plus this distance. You can take this distance, which is nothing but EC squared. So this is going to be 2 times of BE is MB squared. Now EC is going to be half of B, right? This length. So it is square there. So it's going to be 1 over 4 times of B squared. Now BC, what is BC? BC is A squared and BA is C units. So therefore you have this formula. A squared plus C squared is equal to 2 times of MB squared positive B squared over 4, right? So in fact you can extract, you can use this to extract any formula for that matter. Now let me just use this one, this part of this vertex. The vertex is flowing, or I would say the median is flowing from C. So if I were to write that formula for MC, then this is going to be AC squared plus BC squared is equal to 2 times of the median, which is nothing but CF squared positive. Now you got this this part, right? You can either take it as this part or this part. It doesn't matter. So if I were to take this as CF squared plus BF squared, it's going to be equal to 2 times CF is going to be MC squared positive of 1 over 2 times of C squared, right? I mean 1 over 2 times of C, that's going to be 1 over 4 times of C squared, that's going to be C squared over 4. And on this side AC squared is B squared and BC squared is A squared. So you got A squared positive B squared is equal to this entire formula. So it's a lovely formula given by Apollonius theorem. So this is actually the first formula. Second one I've shown you. The third one is also over here. So 1, 2, 3. So now the question comes, how are we going to apply this? That's the most important part. So let me show you that application also. So I will be giving you this question. This is a lovely question to show the application of Apollonius theorem. Let me write that question down. In the figure below, triangle ABC is a right angled triangle and AC is equal to 100 units. Also, we've been given that AD is equal to DE is equal to EF is equal to FC. We are expected to find the value of BD squared plus BE squared plus BF squared. So this is required. Now let me draw the figure. The figure is given in this fashion. So you have and BE actually divides, so this is A, B, C, and this is a right triangle, so this hit is at the center. And this AC is 100 units, so this is D, this is F, and we're given all of these are equal. AD is equal to DE is equal to EF is equal to FC. Now, since AC is equal to 100, so this would mean each of these sides, AD is equal to DE is equal to EF is equal to FC is equal to 1, 2, 3, 4. That means we got 25 units. Now, this portion BE is equal to half of AC. So that would mean half of 100, which is equal to 50. So this BE is equal to 50 units. So that is also a very important observation that you will have to note there. So I place that value there. Now just observe the question. They're asking us to get BD squared plus BE squared plus BF squared. So this is BD, this is BE, and this is BF. So what I wish to do is I would like to consider triangle ABE, or you can consider triangle BAE, whatever you wish. So if I were to consider triangle ABE, so this is the part I'm considering. You got this to be the median. BD is the median. So just ignore the other parts. So this is the triangle that we are left with, and there is a median flowing from B. So that would mean applying Apollonius Theorem, we get, so what do we get? This is going to be AB squared plus BE squared is equal to 2 times of the median BD squared plus AD squared. Now we have BD, so let me have that BD squared there, and AD is 25 units, so it's going to be 25 squared, and AB squared, we got to place that AB squared plus BE squared. So what is BE squared? BE squared is 50 squared. So now we have a equation. So let me take that as 2. You don't have to do anything, just take it as 2. So now moving on, consider triangle. We will have to consider triangle B, E and C. So you got BF to be the median, and applying Apollonius Theorem we get, so what do you get? This is going to be BE squared plus BC squared is equal to 2 times, this is the median we are targeting, so that's going to be BF squared plus EF squared. EF is 25, EF squared is 25 squared, so it's going to be BF squared, positive EF is 25 squared, and over here you get BE squared positive BC squared. So BC squared, do we have a value for BC squared? No, just place BC squared, but BE squared, we got a value for BE squared, 50 squared. So I'm just placing it. So this is going to be 50 squared plus BC squared is equal to 2 times of BF squared positive 25 squared. So this is another system 3. Okay, now what I wish to do, I would like to add 2 and 3. So let me do that. So AB squared plus BC squared, AB squared plus BC squared, 50 squared, 50 squared. So it's going to be 2 times of 50 squared is equal to, this is going to be 2 times BD squared plus 2 times of 25 squared plus 2 times of BF squared plus 2 times of 25 squared. So this is what we've got. Now let me rewrite this as 2 times of BD squared plus BF squared plus 2 times of 25 squared plus 25 squared, 25 squared plus 25 squared. So this is what we got on the right side. On the left hand side, you got AB squared positive BC squared. Now this is given to be as a right triangle. AB squared positive BC squared is equal to what? It will be equal to AC squared. So I'm using this part of the page. So AB squared plus BC squared is going to be AC squared. So I'll write that down. AC squared positive 2 times of 50 squared. This is 0025, right? So 2 times of 50 squared is going to be 0025 is equal to, you got 2 times of BD squared plus BF squared. Just write that down. 2 times of BD squared plus BF squared positive 25 25 625. What do you get? 625 times 2. So let me write that down like this. 625. So you have 2 625s. So I have to first add them down. So 5 5 10 1 4 5 12. So this is going to be 1250. I've got 1250. So I can take in fact I can just retain as it is. I can just retain this as it is. So BD squared plus BF squared. Now this one I can push it to the other side. Now what is AC? AC is given to be as 100 squared. So on the left I got 100 squared positive 0 0 5 2s are 10 1 2 2s are 4 5. So this is 0 0 0 0 1 plus this. So it's going to be 5 0 0 0. So this is going to give me 1 5 0 0 0. So this is what I've got on the left. So let me write that down. 1 5 0 0 0 is equal to, now I did not push this to the left side, so I will have to push that. Before I could push it, let me just retain it like that. So 2 times of 1250. Now if I were to push it, this is going to be minus 0 5 2s are 10 1 2 2s are 4 5 and 2 1s are 2. This is what I get on 2 times of BD squared plus BF squared. So you subtract this. If you subtract this, you get 0 0 10 5 4, you get 2. So this is what you get is equal to 2 times of BD squared BF squared. So therefore BD squared plus BF squared is equal to 12500 divided by 2, which is nothing but 6 times 2 times and 5 times 0. So this is what you get for BD squared plus BF squared. But what do you need? They're asking us to find BD squared plus BF squared plus BE squared. So you add BE squared here. So therefore BD squared plus bf squared plus be squared is equal to 6250. What is be? Achha, be is 50, so be squared is going to be 50 squared, so that's going to be 2500. So which is nothing but 6250 and 2500 is 0578. So this is the value you are getting. So let me conclude this. So therefore BD squared plus BF squared plus, so this is actually BE, right? So I should have placed BE. This is BE squared. So therefore BD squared plus BF squared plus BE squared is equal to 8750 units. I don't know what units they would give. Whatever units they give, just place that. So this is solution 8750. And how did I get that solution? All because of applying Apollonius theorem. So this is a competitive question, right? This is a competitive question that was posed in one of the competitive examinations, high-end examinations, and as you can see, to achieve the solution you need to know specialized knowledge, otherwise you wouldn't be able to solve this. So without this question cannot be easily obtained its means. So having given you this, I hope this was useful, and until we meet again, enjoy your day. Thank you.